All right, I should be live. Let's double check. Everything seems to be good. All right, perfect. I just realized that I may have sent out the wrong time in my tweet. I should check. Wait. Nope, 7 a.m. I just have been getting retweets, I guess, of the Node.js meetup that were 7 p.m. So I was like, did I say 7 p.m. today instead of 7 a.m.? Good morning, Avaris. Welcome to the stream again. So we're on to automated tests, chapter 11. This is an awesome topic because I love doing test-driven development whenever I'm working for a company, whenever I'm like actually developing something that matters for real, because I feel that is the best way to make sure that the quality of what we have doesn't degrade over time. And I find that it's the easiest thing to like fix bugs quickly and try not to like regress and create previous bugs that we used to have. So this is something that's actually pretty important to me. So I'm glad we're going to go over this. And we had tried to do some testing in the library and I couldn't exactly figure out how to do it. So I'm glad we're finally here that we can. And since it's 7 a.m. now, let's go ahead and get started. So, writing automated tests. In his 1972 essay, The Humble Programmer, Edgar W. Dijkstra said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. That doesn't mean we shouldn't try to test as much as we can. Correctness in our programs is the extent to which our code does what we intend it to do. Rust is designed with a high degree of concern about the correctness of programs, but correctness is complex and not easy to prove. Rust type system shoulders a huge part of this burden, but the type system cannot catch every kind of incorrectness. As such, Rust includes support for writing automated software tests within the language. As an example, say we write a function called add2 that adds 2 to whatever number is passed to it. This function's signature accepts an integer as a parameter and returns an integer as a result. When we implement and compile that function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we aren't passing a string value or an invalid reference to this function. But Rust can't check that this function will do precisely what we intend, which is return the parameter plus 2 rather than, say, the parameter plus 10 or the parameter minus 50. That's where tests come in. We can write tests that assert, for example, that when we pass 3 to the add2 function, the return value is 5. We can run these tests whenever we make changes to our code to ensure any existing correct behavior has not changed. Testing is a complex skill. Although we can't cover every detail about how to write good tests in one chapter, we'll discuss the mechanics of Rust testing facilities. We'll talk about the annotations and macros available to you when writing your tests, the default behavior and options provided for in your tests, and how to organize tests into unit tests and integration. And then before I go on, I actually just remembered that I wanted to mention an issue that was created yesterday, or I think it was yesterday morning. I had been mentioning that I was going to look for more resources on lifetimes, and a member of our community has provided one. And this is a lot of work-related issues. Find mine? No, of course, mine is now hidden in here. Okay, well, let's just go to my home and find Learning Rust repo. Someone posted it. Lifetimes by MRE Coelho. Yeah, Miguel. So this is an awesome resource. I haven't had a full time to like really dive deep into it. I skimmed through it and it looks really good. There's some things that I think are confirming what I believe, and some things that I am not, that I still need to like really read on, and I haven't had a chance to read these references yet. But the really cool thing is that this is now permanently part of the Learning Rust repo. So yeah, Stacking, you were asking for this. Well, here it is. I'm going to label this as information, and it's going to join the other ones. What is also mentioned, and Danny commented on the YouTube archive as well, saying that that NLL is coming and will make things a little bit easier for everybody. But I also agree with you, Miguel, that that sort of understanding what's going on behind the hood, because it's, I mean, I haven't looked into NLL, but the way that it was written sounds like it's not really going to change anything from how it works behind the scenes. It's going to change when we have to use it. It's just going to be better at deciding, at like automatically creating, automatically annotating the lifetimes. So anyways, this is an awesome resource that I will definitely be diving into, and I want to make sure everybody can see where it is so that they can also dive into this and take a look at it. So thank you again, Miguel, for that. That was an awesome contribution. Let's move on and start up with, we have testing 11.1, writing tests. How to write tests. Tests are Rust functions that verify that the non-test code is functioning in the expected manner. The bodies of test functions typically perform these three actions: set up any needed data or state, run the code you want to test, assert the results of what you expect. Let's look at the features Rust provides specifically for writing tests that take these actions, which include the test attribute, a few macros, and the should panic attribute. So I have seen the should panic before pop up in code as like, whenever I'm writing panic, it's like, are you sure you don't mean should panic? So looks like we're finally going to use that here. The anatomy of a test function. At its simplest, a test in Rust is a function that's annotated with a test attribute. Attributes are metadata about pieces of Rust code. One example is the derive attribute we use with structs in Chapter 5. To change a function into a test function, add the test attribute on the line before a function. When you run your test with the cargo test command, Rust builds a test runner binary that runs the functions annotated with the test attribute and reports whether each test function passes or fails. In Chapter 7, we saw that when we make a new library project with cargo, a test module with a test function in it is automatically generated for us. This module helps you start writing your tests so you don't have to look up the exact structure and syntax of test functions every time you start a new project. You can add as many additional test functions and as many test modules as you want. We'll explore some aspects of how tests work by experimenting with a template test generated for us without actually testing any code. Then we'll write some real-world tests that call some code that we've written and assert that its behavior is correct. Let's create a new library project called Adder. All right, so let's create a library here. So we'll do, we're in chapter 11 now. So take chapter 11. Oh, we're already in here. Cargo new, oh, I should -- lib adder. And we'll open up code. So yeah, what the book is talking about is this code right here, where now we have this module test. So what's interesting is that we have configuration test and this, function module tests. I'm curious, if I run that cargo test, will it work? It should, right? Yep, test result, okay, pass one. So this is, to me, this is not an it works, but more of like a canary test. And to me, like what a canary test, and I usually do begin with a canary test, which is, okay, have I set up the entire testing ecosystem correctly right now? If this fails, then there's no reason to bother trying to write real tests. Let's just fix the testing system first. And if this suddenly stops working, well, then I'm not going to worry about the other tests failing because, well, I've done something horrifically wrong when attempting to run these tests. Okay, so it adds this for us. For now, let's ignore the top two lines and focus on the function to see how it works. Note the test annotation before the function line. This attribute indicates this is a test function, so the test runner knows to treat this function as a test. We could also have non-test functions in the test module to help set up common scenarios or perform common operations. So we need to indicate which functions are tests by using the test attribute. The function body uses the assert equal macro to assert that 2 + 2 = 4. The assertion serves as an example of the format for a typical test. Let's run this to see that this test passes. So we did that, it ran. Cargo compiled and ran the test. After the compiling, finishing, and running lines is the line running one test. The next line shows the name of the generated test function called itWorks and the result of running that test, okay. The overall summary of running the test appears next. The text test results okay means that all the tests pass, and the portion that reads 1 passed, 0 failed totals the number of tests that passed or failed. Because we don't have any tests we've marked as ignored, the summary shows 0 ignored. We also haven't filtered the tests being run, so the end of the summary shows 0 filtered out. We'll talk about ignoring and filtering out tests in the next section, controlling how tests are run. The 0 measured statistics for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in Nightly Rust. See the documentation about benchmark tests to learn more. That's actually going to be pretty nice to be able to like see how fast things are running. I wonder if it's going to be like more profile type tools in there as well. That'll actually be really cool. The next part of the test output, which starts with doc test attr, is for the results of any documentation tests. We don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. This feature helps us keep our docs and our code in sync. We'll discuss how to write documentation tests in the documentation comments section of chapter 14. For now, we'll ignore the doc tests output. Let's change the name of our test to see how that changes the test output. Okay, so we're changing that, and then we're running cargo run again, or cargo test again. And what's interesting, still has test results okay. Oh, tests, Canary tests. And I think this test right here is due to mod tests. So we could have like, so this is a module in there. So the one question is, do we want to have like its own mod that tests the other mods, or do we put the tests in the mod, in each mod, and just like have it there? I could see both, especially if like modules will be working together. Let's add another test, but this time we'll make a test that fails. Tests fail when something in the test function panics. Each test is run in a new thread, and when the main thread sees that a test thread has died, the test is marked as failed. We talk about the simplest way to cause a panic in chapter 9, which is to call the panic macro. Enter the new test, another. So your source librs file looks like this. So we're going to create this test, another, and then just immediately panic because it's supposed to fail. So we this test function failing on purpose, or I'll just call it failing. And in this case, we're just gonna straight up panic. Aborting early. So we'll save this and let's run it to see how it handles a failing test. So it just has this ... failed here. That a little bit bigger. And this is something similar to see in other test runners in other languages too. Run the test again using cargo test, and then we'll have this output. Instead of OK, the line test test another showed failed. Two new sections appear between the individual tests and a summary. The first section displays the detailed reason for each test failure. In this case, another failed because it panicked at make this test fail. Take a look at what this output here. Yeah, we have failures, which is just like the actual error message here. And then more generic, like, hey, here's the test information. Yeah, it looks like Rust didn't really change much for its test runner. It looks like it even has all the same keywords as all the other testing systems. Yeah, I mean, I think it would be interesting if they used sort of like a behavior-driven language as well, but it doesn't really matter because you could write tests in whatever way you want to. And it looks like this is a pretty flexible way of doing tests because you just put it in wherever you want. The next section lists the names of all the failing tests, which is useful when there are a lot of tests and lots of detailed failing test output. We can use the name of a failing test to run just that test, more easily debug it. We'll talk more about ways to run tests in a controlling how tests are run section. That's actually interesting. I wonder if it's as simple as a cargo test, and then, for example, we want a Canary Test. Yep, it's as simple as just putting the name in here. The summary line displays at the end. Overall, our result is failed. We had one test pass and one test fail. Now that you've seen what the test results look like in different scenarios, let's look at some macros other than panic that are useful in tests. The assert macro provided by the standard library is useful when you want to ensure that some condition in the test evaluates to true. We give the assert macro an argument that evaluates to a Boolean. If the value is true, assert does nothing and the test passes. If the value is false, the assert macro calls the panic macro, which causes the test to fail. Using the assert macro helps us check that our code is functioning in the way we intend. In chapter 5, listing 5.15, we use a rectangle struct and a can-hold method, which are repeated here in listing 11.5. Let's put this code in source librs file and write some tests for it using the assert macro. Okay, so we're gonna create. Okay, so let's actually just take this directly and throw it. Now, where do we want to put this code? Let's put this code in the source librs file and write some tests for it. We want to put it in a module. What I find, so it looks to me like they're not putting it in a module. They're doing something like this, which doesn't feel like what I would do normally. We have pub. Yeah, this, I mean, so this feel like, it feels, I guess, weird because I'm in a library and I want to be like putting this in a module and then importing this module, or maybe doing it inside of this module here. I don't know. And so the tests, what are we doing here? So implement rectangle, can hold. So is this like larger than the other one? That's all it really is. It's a Boolean. Self.length is greater than other.length, and self.width is greater than other.width. So we don't need to have this failing anymore. So we can check this to check rectangle. I'm not really sure what the best naming conventions are here too for these tests. I'm used to things like describes and its and other stuff. So not having any of those and just doing functions, not completely sure the best naming case for it. I might even call this like rectangle struct. So we're going to assert. So I guess we first need to create the rectangle, right? So it's going to be let rect equals rectangle. I'm going to put in length. Length is going to be U32, so it can be something like 15. I'll also do this rect small, and width is 15, so a square here. And then let rect large equals rectangle, and I will put length, maybe double it. Then the idea, expected expression found closing bracket. It's a structure, so I should be able to create it like this. But I'm wondering if I'm not able to get it, if I'm not able to see it right now. Although now all that's gone. It disappeared, so I'm not really, maybe code is just really lagging behind with telling me errors right now. Okay, so if I want to do this, I want to assert, and it's going to be whatever the two things are that they're going to be evaluating to true. So it's going to be rectangle, so can hold other rectangle, self.length is greater than other. So I want to do this with the large one. So it's going to be rect large dot can hold, and then rect small. So assert that, and the question is, where do I put any text, or do I even put any text at all? If I just run this, let's see what happens. Oh, I don't want Canary Test anymore. Test again. And it's, okay, so it's telling me rectangle not found in this scope. So do I need to put this entire thing inside of this module? And so this is what I ran into when I was trying to do my own test, was like bringing them into scope so that my test could find them. So if I do that, expected reference found a full struct, so now it found it, so now I have to give it a reference to this. And okay, so that works. It got the Boolean. Now if I did it the opposite way, so also assert, and it's going to be rect small can hold a reference to rect large. This should fail. And it does. Okay, perfect. So our failure, thread test panicked at assertion failed. Rect small can hold rect large. So perfect. Back to the book. The can hold method returns a Boolean, which means it's perfect for use case for the assert macro. In listing 11.6, we write a test that exercises the can hold method by creating a rectangle instance that has a length of 8 and a width of 7, and asserting that it can hold another rectangle instance that has a length of 5 and a width of 1. Oh, interesting. So one thing I notice here, this is use super. Note that we've added a new line inside the test module, use super star. The test module is a regular module that follows the usual visibility rules we covered in chapter 7 in the privacy rules section. Because the test module is an inner module, we need to bring the code under test in the outer module into the scope of the inner module. We use a glob here, so anything we define in the outer module is available to this test module. We've renamed our test larger can hold smaller, and we've created 2 rectangle instances that we need. Then we called the assert macro and passed it the result of calling larger can hold smaller. Where's the super scope coming from in this case? Like, where is super? Is it some kind of special keyword for test? So I'm used to seeing super in an object-oriented language. Like when you create a constructor in a class, super is calling the methods and properties and sort of like bringing them in from the extended classes. So it's actually a little bit weird to see it here, although I'm wondering if it's being used in a similar way. The next thing is they're not showing the code still, so I'm wondering, is it the same as pulling this, putting it here, and of course it's not going to be in scope. Will we use this use super star? Will this, I'm getting green again. Struct has never used rectangle. Right here. I'm guessing because of this error right here, it's not being done correctly. Do I need to put this in wait. Did something weird here. Mod tests. I removed the wrong thing. Hold on. I only want to bring this stuff out. Oh, I still need the drive debug. Still an important part here. We need drive debug, struct rectangle, the mod tests. Okay. I feel like I've done something weird here. This should all this up here. Untab UN. Okay, so we have our drive debug. Public struct rectangle is not in a module right now, but we can try that next time, like for the next thing. The other thing I notice is if I save it, I'm not getting the same. Now I'm not getting little squigglies that's telling me that it's not going to work. So maybe things are better now. No, still not found in the scope. So let's create an actual module for this to go in. So we can do mod mod rect. Tab that in. And then we have these things inside of this module. If you're, oh, I forgot the super again. You're right. Okay, so let's bring that in. It was inside of mod tests right here. Use super colon star you should be tabbed back that way. Let's try this. Okay, this works. Basically, this one is doing opposite. Super refers to the parent module, so it is being used in the same way as an object-oriented language, then, right? If I created a module, because like nobody's gonna just create their module and all their stuff like this. Everybody's gonna put it inside of like module my rectangle. Like that. And I can't remember, is modules don't need to be in this weird camel case format. It's just like rectangle. I'll call it shapes. The book should really explain that it kind of gave no clue how to set up this and what super is. There's been a few other times where it's done that. I noticed that there's a future section in the book that's going to talk about is Rust an object-oriented language, and I think that is going to be what we see, maybe super coming in and how it works. Struct is never used rectangle. So because I have this module shapes, use super, but do I have to also pull it in like extern shapes? I shouldn't need like an extern create shapes now. Oh no, because the extern create like this thing. To use super shapes colon star. Oh, so it did find that. Field length is private, so it found it, but because these things need to be public. So I guess like a question is the best practice when testing here, it's either super shapes star or shape star now. Yeah, okay. So I got that. Is the best practice to actually put these tests inside of the same area where, like, not just have a test section, but rather for each of these modules, we have tests that run these. My guess is that it's best to put them all together here, so that way we don't have to do any use, or like that way private things can be tested as well. Otherwise, we need to mark everything as public, and that doesn't seem right. So if I do this, now I have this rectangle struct, and okay, so let's try it. Okay, so failed rect can hold, small rect can hold large. It's running the test properly, but it's also telling us that method is never used can hold. And I think it's saying that because it's not a public. So we want this one to be a public. You forgot to comment out the other test. I mean, this test is fine, and I think what I would want to do is reverse it. Where it's like, hey, you can't, like, it should be the opposite. But in a real world situation, we're building the structure so that an external module can use it. So we'd want a public shape, mod shapes, public struct rectangle with a public length and a public width, and a public can hold. Do I need to do the public on the implement? Unused import, yes. So I don't need this anymore. And now we should have full green again. Yes, okay. So what we've got, in my mind, the best way to use these testing is going to be put these tests in the modules themselves, probably as close to the functions as possible, so that way as we're working on them we can sort of change it around. If they're going to use multiple functions or multiple modules, that's when I think we would put them out here and then import them in with that use super and then the name of the module. But this allows us to like make a change, like very quickly go back and forth and fix things up, which is actually better than a lot of other testing frameworks that I've used, where it's completely different files and you have to like context switch back and forth and then maybe like have a really big monitor to sort of see everything going on at the same time. I'm still a fan of having tests in its own folder so you don't clutter up your code with tests. I mean, I could see that. I think I understand why doing this is helpful. I think it's gonna be, I'm gonna have to play with it and use it, and then I'll probably be able to make a decision about which one I like more. Okay, so we did. Note that we've added a new line instead of test module. Use super. This test module is a regular module that follows the usual visibility rules we covered in chapter 7 in the privacy rules section. Because the test module is an inner module, we need to bring the code under test in the outer module into scope of the inner module. We use a glob here so that anything we define in the outer module is available to this test module. We've renamed our test larger can hold smaller. We've created the two rectangle instances that we need. Then we called the assert macro and passed in the result of calling larger can hold smaller. This expression is supposed to return true, so our test should pass. Let's find out. So I guess super was used in chapter 7. I guess I don't remember it being used. That's actually a really good question. I don't remember it being used either. It does pass. Let's add another test. They're doing exactly what I did, which was now larger can hold smaller. Because the correct result of the can hold function in this case is false, we need to negate that result before we pass it to the assert macro. So then we put in a bang. They still didn't make it clear how they wanted their test set up, though. That's true. I'm guessing they just expect you to copy paste it in and not have an actual module, because of the way they're using the super worked for us when we did that. 2 tests that passed. Now let's see what happens to our test result when we introduce a bug in our code. Let's change the implementation of the can hold method by replacing the greater than sign with a less than sign when it compares the lengths. Well, so like all of these things are pretty standard. It's now going to just tell us, no, it's going to fail. Our test caught the bug because larger.length is 8 and smaller.length is 5. The comparison of lengths in can hold now returns false. 8 is not less than 5. So testing equality with the assert equal and the assert not equal macros. A common way to test functionality is to compare the results of the code under test to the value you expect the code to return to make sure they're equal. You can do this using the assert macro and passing it an expression using the double equals operator. However, this is such a common test that the standard library provides a pair of macros, assert equal and assert not equal. To perform this test more conveniently, these macros compare two arguments for equality or inequality respectively. They'll also print the two values that the assertion fails, which makes it easier to see why the test failed. Conversely, the assert macro only indicates that it got a false value for the double equal expression, not the values that led to the false value. In listing 1117, we write a function named add2 that adds 2 to its parameter and returns the result. Then we add this function using the assert equal macro. So let's try this with a little bit of a test-driven development here and sort of see what errors we also get. So you have public mod shapes. If I create another pub mod adders, and so in here we have pub fn. Oh, I want to do the test first. So it's going to be test function add to test. So we'll say, okay, I guess what we really want to do is assert equal, and we're going to call this function that doesn't really exist yet. So it's going to be the add2 function. We're going to pass it in 2, and we should get 4 back. So if I do that, and let's go ahead and run this. So I should get an error right away saying like, hey, add2 doesn't exist. Not found in this scope. So let's do the defensive style of test-driven development. We'll do the bare minimum code to make that error go away. So we'll have a pub function add2, and there we go. Done. Okay, so this error, this function takes 0 parameters, but 1 parameter was supplied. Expected 0 parameters, expected this. Okay, so now we know, okay, well this takes something. So this is going to be a number, and it's going to be a I32, and that's it. It takes unused variable number, mismatch types expected. This is interesting. Expected nothing to be returned, found integral variable. So it is actually saying like, hey, this output 4 is not the same as this output, which was just nothing at all. So we need to make sure that we return something. And of course it wants us to return 4. So let's just return 4. Oh, expected, we need this to return I32. And then we can return 4, which will make the test pass. So test pass, we're good. Everything works. Right? I mean, that's how we do it. So of course not. We need to, the developer in this case is being mean. So we need to write another assert equality, and we're going to pass in add2 again. but this time we'll pass in 4 and expect 6. Let's see, the developer has no choice but to actually do it correctly now. Now it's saying, okay, now we need, so the left one is 4, the right one is 6. So pass it back in. We can't just do 4 anymore. We'll take number and add 2. And then this would cause everything to succeed. All right, so I feel that this makes it a little bit easier to do test-driven development because the code is right here. One thing that I have run into in the past when I've done test-driven development is writing a bunch of tests and then forgetting exactly what I was trying to set them equal to. And so having to put, like, on the left side of the screen, one of the tests, like the test that I'm writing, and on the right side, the actual code that I'm writing. In here, it's just up and down. Okay, so we have assert equal. The first argument we gave to assert equal macro 4 is equal to the result of calling add 2. Oh, it's interesting. So they did opposite, where they gave 4 first and then add 2. They ran the add 2 function later. And the OK text indicates that our test passed. Oh, another interesting thing. Look at this. They're using it in the function names to sort of like mimic the it that we get in like behavior driven or traditional test driven development. Let's introduce a bug into our code and see what it looks like. I don't think we need to do a bug. If the code is super long, you'll still have to scroll or split the pane anyway. That's true, but that's the other thing is like maybe this will help in a more like functional programming style where we can have lots of small functions and then the tests near that function. I mean, this is all just me like guessing at how it's going to be when I do it for real, but that's something that I would try to strive for is like, okay, let's make sure the function is only doing one thing. So hopefully because of that, it's not too long. Our test caught the bug. It adds 2. So it shows us all these like where it is. Note that in some languages and test frameworks, the parameters to the functions that assert 2 values are equal are called expected and actual, and the order in which we specify the arguments matters. However, in Rust, they're called left and right, and the order in which we specify the value we expected and the value that the code under test produces doesn't matter. We could write the assertion in this test as assert equal add to 4, which is exactly what we did, which would result in a failure message displayed. Assertion failed, left does not equal right. Okay. The assertion not equal macro will pass if the 2 values we give it are not equal and fail if they're equal. This macro is useful for cases when we're not sure what a value will be, but we know what the value definitely won't be. Let's see. If our code is functioning as we intend. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we run our tests, the best thing to assert might be that the output of the function is not equal to the input. Under the surface, the assert equal and assert not equal macros use the operators double equal and not equal respectively. When the assertions fail, these macros print their arguments using debug formatting, which means the values being compared must implement the partial equal and debug traits. They're just using double equal and not equal. All the primitive types and most of the standard library types implement these traits. For structures and enums that you define, you'll need to implement partial equal to assert that values of those types are equal or not equal. You'll need to implement debug to print the values when the assertion fails. Because both traits are derivable traits, as mentioned in listing 512 in chapter 5, this is usually as straightforward as adding the derive partial equal debug annotation to your structure or enum definition. So if I do this, so we have derive debug. We also want to derive partial equal. So if I do that, can I now so rectangle function rectangle struct adds rectangle struct. I wonder if I now can do another test in here. So function it is equal. So let first it's going to equal a rectangle that has a length of 10 and a width 10. We're going to have a second, which is exactly the same, and I want to now assert equal. That first and second. So let's see whether or not this partial equal works here. Yeah, it seems to. It is equal. So the partial equal, I'm guessing, is making sure, like, okay, first dot length is equal to second dot length. First dot width is equal to second dot width. I could probably create my own version of that in case I want to say, like, oh, well, ignore some of these. They don't matter. It's just that these other fields and keys and values, they're the ones that really matter. Let's see. This is going to be a longer section, so I don't believe we're going to be able to get through it completely before 8 o'clock comes. So I think now is a good time to sort of begin winding down the stream. So let's go ahead and add these in to the README here. Vim README. We are on chapter 11. Adding custom failure messages. And this is the URL. Perfect. So we had another comment. Some of you may remember Felix. He stopped by a YouTube comment yesterday and left a really awesome message saying, hello, he's not able to make the streams very often these days, but has been continuing to watch some of those videos. So awesome. Thank you, Felix, for watching the VODs. I am super happy to hear that that everything is, you're still watching and you're still enjoying the streams, and I hope that someday we'll have you back on live again. We'll be able to chat and say hi. Let's see, and I think these can be closed. We can send all of these ups. So testing, panic. I shouldn't use a bang there. Panic, bang, and Actually, it's not panic bang. What was it? It was assert bang. Assert bang and assert equal bang. And we'll send this on up to the Learning Rust repo on GitHub. I have that linked down below in the stream description or the video description. Let's make sure that all got up here correctly. Oh, I want to learn Rust. Yep, so we're in the correct news section, so perfect. I'm going to put a link to this here in case anybody wants to go and look at that, or if you're watching the VOD, you can also see the link to this. I have also links in the description here and in the YouTube videos that are being archived in the description. I'm generally doing these videos or these streams every single morning at 7, or every single weekday morning at 7 a.m. Mountain Time, and I'm then archiving those over to YouTube. Every once in a while, I stream randomly, either like a meetup group that I'm invited to, or that I'm running, like the Node.js meetup group that we did this last Tuesday, or just some random streams that when I have time, I'll start a stream up. If you want to get notifications when I go live, follow me here or follow me on YouTube for the archives. I also usually tweet out when I'm going to go live, and you can follow me there also. Anyways, with that, that is my closing spiel. Thank you everybody for stopping by and watching and see me struggle through testing. Thank you, Miguel, and I'll see you tomorrow morning. Have a great rest of your day.